Right, so in this video, very briefly, I'm just going to be talking about biconditional statements. So in another video, we talked about just regular old conditional statements, right? So if it's raining, then it's cloudy, right? Now, given the basis that it's axiomatic that rain comes from clouds, obviously this statement is a true statement, right? And we see that, our hypothesis is that it's raining. Our conclusion is that it's cloudy. Okay. Now, as far as biconditional statements go, the only thing that's going to have to happen here is that for it to be biconditional, right, that means it has to still be true in the converse. Okay. So biconditional, right, it has to be true originally, okay, and in the converse. Okay, and what does that mean exactly? Well, that just means that we flip the hypothesis and the conclusion so that it would now become uh, if it's cloudy, then it's raining. Okay, so this, now that we flipped the hypothesis and the conclusion, is the converse, right? Now, does this still hold true? If it's cloudy, right? So it being cloudy becomes the hypothesis, and it raining becomes the conclusion. Yeah, and I don't know why I wrote the word cloudy underneath here, even though I said out loud conclusion. It's really early in the morning. Anyway, so we see that we have a flip, right? But is it still true or not? And the answer is no, it becomes false. So then that means this statement right here, yes, it's true in the OG, right, originally, but it is not true in the converse, right? So that means this is not biconditional. Okay, it is not biconditional. Now, if we think of something else, right? Let's say if it's a triangle, then it has three sides. Okay, so now my hypothesis becomes it's a triangle. My conclusion becomes it has three sides, right? Obviously, obviously, we all understand this is true. We know triangles have three sides, right? Absolutely true to say this. Now, what happens if we flip the hypothesis and the conclusion, right? So right now it's just a conditional statement, but if we prove it true, and we don't really have to prove it, but if it proves true, then it will be biconditional if it's in the converse, right? So if it's got three sides, so I'm going to say it has three sides, then it's a triangle. Okay, so we plainly see, right, that now we have flipped hypothesis and conclusion. Is it still true? I'm going to say absolutely. Okay, if we're talking about a polygon, right? If it's a polygon with three sides, then it must be a triangle. So this is absolutely biconditional. Okay, because it's true originally and in the converse. Okay, so that does it for this video on biconditional statements. Obviously, any questions, come see me or shoot me an email. Goodbye.